In my last video, I showed you the basic simple concepts of NumPy and how to reshape an array from one dimensional to two dimensional or vice versa. So in this video I'll be talking about indexing a matrix. So matrices are nothing but they are like two-dimensional arrays. So we will be following that. So starting with defining a matrix. So here you define the array in two-dimensional form. Twenty-four, 23, 21, 32. 76, 54, 32, 12. And the last row is 98, 6, 4, 3. Let's run this. And if you want to see what is there in the simple matrix, you can simply type this. Maybe you can print it so you can only see the elements or what is there inside this variable or inside this matrix. So now it shows that this is a matrix with 20, 20, 50, 21, 23 like that. Okay. Now let's do some indexing. So simple matrix, and you want to get the first element. You want to get the first row and the last of the last column. So what is that element is going to be? So that element is going to be 23. In the same way, there is another method of doing the same calculation, same indexing. So if you simply remove them and put a comma, it means similar thing. Now if you are interested in getting a complete row, so you will get so this is nothing but this is going to be the fourth or last row, which shows 98, 6, 4, 3. So basically the first one, the first index gives you the row index, and the second index after the comma is called column index. So whichever number you put before the comma, that will be row index, and the number that we are going to put after comma is called column index. Again, as we know that in Python we calculate the number index minus 1. So that is why this is the fourth row is actually the third index. Let's define another matrix. This is because we need some calculation from let's define another matrix. Let's define another matrix called sample matrix. So if we want to see the first sample matrix, and if we want to see the index, oops, okay, so this should be in capital. So what it does it show? It shows that, let's, so it shows that we are interested in the columns, the second column and fourth column. So they are all separated by comma. Put those indexes separated by comma. Put those indices separated by comma, and you will see, and you will get the column matrix. In the same way, if you want to get the subset of the matrix in the form of rows, in the form of rows, you can write 2 comma 4 and colon, so that will give you the third row and the fifth row. So that is how indexes work. When we can also use the both row index and column index at the same time. So if we write 1 comma 3, you can see this is nothing but 54 and 56. This is nothing but 54 and 56. Okay, so this is how we work on this. Again, if we want to like replace the comma inside the bracket by column, see what is going to happen. Now we'll see some selection techniques. Let's do some selection techniques or masking. So let's define an array called sample array. So if you want to check whichever numbers are smaller than 10, let's define another variable called bool and use this bool to get the required numbers, the required array. Okay. You can also use the same calculation in another way. There is another way of if you want to calculate the numbers are greater than a specific number, is to define it by a variable. Let's say a is equal to 11, and then you can get it by this. So it will give you all the values which are less than a. A is nothing but 11. Okay. So this is how we can mask the matrix and make selection. Okay. Now we can simply use summation for adding the same arrays. So the corresponding numbers will get added. This is how we can do it. So in the same way, we can do all the mathematical operation or matrix operation using these arrays. Let's say if you are interested in dividing all the numbers, dividing the numbers. Let's say you are interested in dividing 10 by the matrix, then you will get this kind of result. Okay. So these are how matrices work. In this case, here I'm going to add one in each element of the array. Then as a statistical calculation, if you are interested in calculating the variance, just write var. Var is a function which calculates variance for everything in the sample array. So if the sample array is this, it will calculate the variance of the sample array just by typing var. Okay. In case I have already explained this in my last video. In case you are interested uh, in a random numbers which will have 6 rows and 6 columns, just write random.random. Okay. So this is how it looks like. This is for calculating the standard deviation, and then similarly in the same way you can calculate the mean as well. So this is how you can calculate the mean. Again, you can use string variables. You can also use string variables to create an array. Okay. Couple of things about saving the files. So input, output, and saving files. Okay, so we already have the sample array defined in the previous cell. Let's define another array called simple underscore array by using arrange function. You can also check what is contained in this array. Okay. Now we want to save sample array. We want to save sample array into a file named sample underscore array. Okay. So we can do this by np dot we can do this by doing np dot save and writing the name of the file where you want to save it, and then the name of the array that you want to save in that file. So when we run this sample underscore array and sample array, you can go and check your uh, Jupyter home. You'll see that the file must have the file is saved here in the Jupyter home. Okay. In the same way, if you want to save more than one file, for that we have a function called save z. Again, the same way you have to provide the name of the file, and then you need to provide the two variables, both two or more arrays, and it will save it there. So in the same way, if you go to Jupyter home, you can see that the file has been saved. So this is how it can be manipulated. Once you save the file, you need to load the file as well. And for loading the file, it is again the reverse of save is load. So just put np.load and then simple array, and it will load that array. The same way you can load both the arrays. And this, if you write archive, just see what happens. So it shows that it is a zip file, and you want to show one of the files, one of the array. If you know the name of the array, just write the name of the array, and you will have. If you know the name of the array, you have to write it in the quotation, and it will show the name, and it will show the complete array. In the same way, if you want to display the other array, just write the name inside the single quote, and it will display the other array. Okay, you can also save it in a text file. For saving text file, save.txt is the command. You can use delimiter as well, and this is how save.txt file will be created in the home. So you can see text underscore file.txt. So this is how it works, and the opposite of save is load. So you can also load the file by typing like this, and you will get the file loaded into it. So this is how NumPy works. There are lots and lots of options in NumPy. You can explore it yourself. But to start as a beginner, I think this much function you should know, so that it will be easier for you to manipulate your arrays or data. Uh, as we move on, as we go into other packages, we'll keep taking references from NumPy. So I'm stopping it now, and we'll see you on the other side. In case you have not liked or subscribed, kindly click on the button below. Thank you so much.